This is our topic 5 cycle 2 homework video. We just wrapped up looking at circuits in series and how they share voltage. Today in the lab you went ahead and found a way to make the two bulbs glow brighter by connecting them in parallel, meaning there's two paths parallel to each other, so a charge only has to go through one bulb, it does not have to go through both. So a parallel circuit allows a charge to just go through one bulb. Basically it gives it options for two or more paths, whereas a series circuit, a charge must go through every single resistor. So take a look at the circuit on the left. Trace the flow of current from positive to negative. It would go along the wire through the light bulb 1, through light bulb 2, and then back, meaning they have to share that voltage. On the right, we have our new improved design. A charge can go out of the battery. Now here it has the option to go to the right or down this wire. So it can go down this wire, through this bulb, and back to the battery without having to go through that second bulb. Or alternatively, a charge can go down through the second bulb and back without having to go through the first. Because a charge only has to go through one of the bulbs, it can leave all the voltage it got from the battery in that bulb. They don't have to share voltage. For that reason, in parallel, the light bulbs, just like you found in class, they have the same voltage as the battery. They don't have to share that voltage. This also decreases the overall resistance of the circuit. So the current here splits. So because there's two pathways, just like if a river splits, when it comes back together down here, the total electricity flowing down here going back into the battery is the sum of electricity in each branch. So basically the electricity comes back together, so you add up the total current in each branch. So there's more current in the whole circuit. And the current is different if you're on one of these branches than coming out of the battery. So in series, voltages add. In parallel, currents add. In series, the voltages, they're splitting the energy coming from the battery. Here, in parallel, current comes out of the battery and then it splits into I1 and I2 for these two resistors. So the sum of our current, you'd add up the current in each branch. But each resistor gets the total voltage of the battery because it only has to go through one resistor. So you start knowing the voltage and use that to find the current, using I equals V over R for each branch. So an analogy you can think about is a toll booth. Here we have a single resistor. Here we have, if we had three resistors in series. So you're going through, and if it's a $3 toll, you're paying $1, $1, $1 at each booth. That's letting far fewer cars flow through. Would be more traffic, which is like more resistance. Here on the right, we have 3 toll booths. So a car that goes through is leaving $3 all at one toll booth. This allows more cars to go through, or more charges to go through, and each one uses all $3 at that one toll booth. Because you only go through one resistor or one toll booth, you'd use all the voltage there. So the voltage changes in that way. Because there's 3 of them in options, more current can flow. So in parallel, more current flows. Each resistor gets the voltage of the battery, so the same voltage. And overall, we have a lower resistance because more current is flowing. So those are major ways in which it's different. Also think of how setting up your parallel physically, what did you do differently when you set up the circuit? And then answer the free response question here. So 4 parts of the difference I want you to address. How is it wired differently? So what did you do in class to set it up differently? How does this affect the amount of voltage each resistor receives? How does the total resistance change? And the total current change of that circuit. So pause right now and answer the free response, and then push play again to watch calculations and answer the multiple choice. So in series, we started with the resistance of the circuit by adding up all the resistors because a charge has to go through every resistor. Then we used that resistance to calculate the current. There was one path, so the current was the same all through the series circuit. So we found the voltage of the battery divided by that total resistance we found. Then we know that the resistors split the total voltage of the battery because they had to go through 2 resistors or more. They're splitting the voltage of the battery between those resistors, and we find that by multiplying the current times the resistor, the resistance of the specific resistor. So V1 equals I times R1, V2 would be I times R2. Let's see how this is different in parallel. In parallel, we're going to start here with the voltage. Because a charge only has to go through one resistor, the voltage that that resistor gets equals the voltage of the battery. So each resistor, each light bulb gets the voltage of the battery. So if I have a 1.5 volt battery and 3 resistors in parallel, each one gets 1.5 volts. So there's no calculation to do there. Start there. Each one gets the voltage of the battery. Okay, then use the resistance to find how much current's in that branch. You know the voltage of the battery and divide that by the resistor, the resistance of the specific resistor or light bulb. So in branch 1, you would find the voltage of the battery divided by the resistance of resistor 1 and to find the current there. Then you do that for branch 2. Because those branches come back together to enter the battery, we add up those branches to find the total current. So then you'll take the individual currents, add them up to find the total current, and then use that to find the resistance of the overall circuit. So my total resistance will equal the voltage divided by the sum of the currents. And all I'm doing here is moving around our Ohm's law equation of I equals V over R. So let's look at an example with that. So in our example, we have 2 bulbs in series. R1 has 10 ohms, R2 has 5 ohms. So we have a 3 volt battery and 2 resistors of 10 ohms and 5 ohms. First, let's look at it in series. In series, we added up the total resistance, 5 plus 10 for 15. We then used that to find the current. Remember, there's one path in series, so there's only one current throughout. And then we found 3 divided by that total resistance of 15 gives us 0.2 amps. And then we went through and calculated the voltage used by each by multiplying that current times the specific resistance. So we had 0.2 times 10 ohms is 2 volts, and 0.2 times 5 ohms is 1 volt. Let's see what it would look like in parallel. In parallel, we're going to go ahead and start with the voltage. Each resistor gets 3 volts. They don't split it because the charge just goes through one. So V1 equals V2 equals V battery equals 3 volts. Then we look at the first branch with resistor 1. We have 3 volts divided by 10 ohms, or 0.3 amps. For resistor 2, 3 volts divided by 5 ohms, or 0.6 amps. Now, in the circuit, those 2 branches come back together. So we have one branch here that meets here. We have the second branch here. So here, leaving the battery and coming back into the battery is the total current. And we solve that by adding the 2 up. 0.3 amps plus 0.6 amps is 0.9 amps. Then we can plug in the voltage of the battery and that overall current to find the overall resistance of the circuit is 3 1/3 ohms. In parallel, the resistance of the total circuit will always be less because you're giving more pathways, just like more cars could flow when those 3 toll booths were split up and you didn't have to drive through all 3. Okay, look back over that one problem and answer your multiple choice. So here's your multiple choice question. A 9 volt battery is connected in parallel to 2 resistors with R1 equals 6 ohms and R2 equals 12 ohms. What's the voltage each receives and the total current? So go through the steps I just did, except for substituting in 9 volt for the battery, and the 2 resistors are R1 with 6 and R2 is 12. Then answer the multiple choice. If you're confused, go back on that last example problem I just went over. Make sure you submit, and you should have a copy of your submission in your email.